Hello, my name is Brittany Kabinski, and I just want to welcome everyone. It is now 1 p.m., so we will begin our presentation shortly. Today, on Friday, November 11th, we have our presentation on environmental site design versus smart growth, given by David Ager and Michael Wagner. For help during today's webcast, please feel free to type your questions in the chat box found in the webinar toolbar to the right of your screen, or call 1-800-263-6317. For content questions, please feel free to type those in the questions box, and we will be able to answer those at the end of the presentation during the question and answer session. Here's a list of the sponsoring chapters, divisions, and universities. I would like to thank all of the participating chapters, divisions, and universities for making these webcasts possible. As you can see, we have quite a few webcasts coming up in the next few months. To register for these upcoming webcasts, please visit www.utah-apa.org/webcast and register for your webcast of choice. We are now offering distance education webcasts to help you get your ethics and law credits before the end of the year. These webcasts are available to view at www.utah-apa.org/webcast-archive. You can now follow us on Twitter @Planning Webcast or like us on Facebook, Planning Webcast Series, to receive up-to-date information on the Planning Webcast Series sponsored by chapters, divisions, and universities. To log your CM credits for attending today's webcast, please go to www.planning.org/CM, select today's date, Friday, November 11th, and then select today's webcast, Environmental Site Design versus Smart Growth. This webcast is available for 1.5 CM credits. We are recording today's webcast, and it will be available along with a 6-slide per page PDF of the presentation at www.utah-apa.org/webcast-archive. At this time, I would like to introduce our speakers for today, David Ager and Michael Wagner. David Ager is the founding principal of Townscape Design, an award-winning town planning firm located in Clarksville, Maryland. David is a town planner and landscape architect with 30 years experience providing creative solutions with a strong sense of place and a framework for long-term sustainability. Townscape Design partners with communities and owners in order to create economically vibrant and beautiful places while enhancing their land assets through the use of practical and sustainable design and implementation strategies. Townscape Design works with private sector, nonprofit, and public sector clients. The firm utilizes an integrated systems approach to town planning and urban design through its complete town planning methodology. In addition to the American Institute of Certified Planners, David is also a member of the Congress for the New Urbanism, the American Society of Landscape Architects, and the National Association of Home Builders. He is a registered landscape architect in Maryland, Virginia, and Delaware. He is a graduate and Dean's Medal recipient from Louisiana State University. Michael Wagner is a senior project manager and an associate with Loiterman Solstad Associates. Mr. Wagner has over 35 years of experience primarily focused in water resources design. His extensive experience includes stormwater management, infiltration, and other water quality systems. He also has prepared floodplain studies and watershed analysis for projects with drainage areas ranging from 30 acres to 70 square miles. And he recently completed an analysis to resolve a major flooding issue with a 7 square mile watershed. Throughout his career, Mr. Wagner has provided clients with creative, cost-effective solutions in regards to stormwater management design and sediment and erosion control permitting. Example of past projects he managed that face water resource challenges are Conterra Town Center, various Prince George's County road improvements, and King Farm. Recently, Mr. Wagner assisted in shaping MDE's Stormwater Management Manual. Mr. Wagner's reputation in the water resource field led to the request for him to revise the Prince George's County Storm Drain and Stormwater Management Manual to incorporate the new ESD requirements. This assignment requires close coordination with Maryland National Park and Planning Commission, Washington Suburban Sanitary Commission, Department of Public Works and Transportation, among others. Mr. Wagner received his degree in civil engineering at Purdue University and is a member of Maryland National Capitol Building Industry Association. Let's welcome David and Michael.
Thank you, Brittany. This is Dave Ager from Townscape Design. Welcome, everybody, and thank you for joining us for this webinar. One of the things that's interesting about this is we've had a long history of stormwater legislation and changes here in Maryland. It's more profoundly in the Chesapeake Bay region. We're the largest TMDL in the country, And that has caused a lot of changes in the way we do business with respect to stormwater and stormwater cleansing. This presentation is a presentation we did at a regional conference in West Virginia, Pennsylvania, Maryland, in Cumberland, Maryland, earlier this year that sparked some ideas and some thoughts at the state level. We are basically concerned, or have identified concerns, with respect to the way environmental design, site design, specifically the way stormwater is done in the state of Maryland, and directly related to how it may be in conflict with smart growth principles here in Maryland. So was the genesis of this presentation, and then we were asked to kind of repeat it yesterday at a state level conference and here today. So we're going to be talking a lot about Maryland and the Chesapeake Bay, and we apologize for that, but it's maybe something that's applicable to your local communities throughout the country. So quickly, what we're going to talk about is smart growth as the best BMP available. So the question is, what's the problem? And really what it comes down to is regulations and implementation. I'm going to kind of set the stage and then turn it over to Mike Wagner. He's going to go through some history, which is important because really what's happened in the state is we started back in the early 70s with floodplain management as our basic, stormwater management, and essentially over time the management practice has moved up the watershed to the point where now we are treating water immediately at the point of discharge, at the top of the watershed versus the bottom. And that's essentially what ESD is. So we'll go through that history in more detail, and then we'll come back and we'll walk through some recommendations or some thoughts that we've had at the state level here in Maryland that may be applicable throughout the country, because we're somewhat of the guinea pig for this sort of practice, and it may be applied elsewhere in the future. So quickly, some terminology. Here in Maryland, we call low-impact development essentially environmental sensitive design. You may hear best management practices, sustainable stormwater management used in other parts of the country. It's essentially all the same thing. It's bringing the watershed practice as close as possible to the point of origin and treating it for both quantity and quality control, and specifically for pollutant and nutrient reduction. And then here in Maryland, we generally refer to smart growth, but in other places you may hear it referred to as green urbanism, walkable urbanism, sustainable urbanism, et cetera, et cetera. But it's the concept of organizing the place for maximum walkability and efficiency, and making it truly a place for people. I'm not going to go through this in great detail, but these are the 10 smart growth principles that are used not only here in Maryland, but have been, you can find these on their website at EPA. But and what it is, it's essentially organizing your place to be as efficient as possible, to use your resources as succinctly as possible. So why are we in the situation we're in? Very quickly, there's a process going on in the Chesapeake watershed where we're monitoring the performance of the watershed. And the watershed had been actually increasing in performance, or getting better, over the last 4 years. But in 2010, we had a problem. Additionally, in 2009 and 2010, there were some legal battles that have made the implementation of this ESD process mandatory versus voluntary, which it was in the past. We essentially weren't meeting our goals fast enough to clean up the bay. And here's some information. You can go on. Again, there's tremendous information at the end of this webinar. A series of links that will also be in the PDF that can link to all the information that we're providing during the session. One of the biggest problems we have here is 10% of the watershed is now in turf, managed turf. So we have a tremendous effluent overload due to turf, and it's actually a greater amount of nitrogen and phosphorus, or as bad as our agricultural practices. So we have specific suggestions for that in this presentation, but this is just one example of some of the things that we're doing here in this watershed that are a problem. The interesting thing about the concept of smart growth, or transit-oriented development, or whatever you would like to call it locally, the interesting thing is it is recognized nationally and here at the state level as the smart growth technique for keeping the bay clean and appropriate, or keeping our watersheds clean and appropriate. The problem is that it typically doesn't transform from theory into practice. Here and just some real quick notes, here in Chesapeake Bay, it's over a 5-state region, including all the way up into New York. Here's a quick link to the site on the Chesapeake Bay TMDL. And TMDLs, for folks who are not familiar, is total maximum daily loads, and that has to do with sediment, nitrogen, and phosphorus impacts on the watershed. And this is again a resolution of the settlement agreement back in 2010 and President Obama's executive order of May of 2009. So we are under the authority of the legislature and the courts to get this resolved, and we have time deadlines, and Mike will talk about that in the future. Now, there are several publications. Not only are people advocating smart growth from several different locations. Congress for New Urbanism, for example, has put out several informational packets on this. But even the EPA has their own recently best management practices that talks about smart growth as a best management practice. But at the same time, with all this information, all the theory out there, and all of the logic associated with it, it doesn't seem to be translating into practice. And we've identified these problems here in Maryland. There may be problems elsewhere, so we'll talk about those later in the broadcast. So there's 3 very high-level opportunities here in the watershed. Primarily, our corridor reinvestment. This is an example from Virginia, done by Dover Coal. It's a regreening of the watershed. And so the question as we go through these that you may want to be thinking about is, how do I integrate stormwater management into this sort of environment and still make it an economically viable reinvestment and redevelopment? We have our towns and villages. These are excellent opportunities for infill development. And it's already been identified that infill development has a 10-fold benefit associated with it versus the same level of development on the fringe of these towns and villages. So the state of Maryland has a very strong state proposal it's a draft state comprehensive plan called Plan Maryland, where we're focused priority funding within these existing towns and villages, and anyone who wants to develop outside the town, if allowed by the local jurisdictions, would not have any financial or support from the state level. And finally, we have the opportunity for redevelopment. We have brownfields, gray fields throughout the watershed. These have a 4.5-fold benefit versus fringe development. And the ability to integrate stormwater management into all 3 of these opportunities is tremendous. So the question is, how do we integrate in an environment something like this? And this is in Northern Virginia again. This is Silver Spring, Maryland, a more than $500 million investment by the state that was started about 10 years ago. And the question I'm putting on the table is, what would this look like if we had to perform stormwater management for every, say, 3,000 square feet of drainage area, or every 10,000 square feet of drainage area? And several of the practices that we'll go through later on actually limit, or most of them limit, your drainage area to a maximum of, say, 10,000 square feet. There's only a few beyond that. So how would this be different? This investment by the state, this tremendous investment by the state, is very successful. This is a project in North Carolina. It's in Charlotte. It's called Phillips Place. The reason I bring this up is in one of the identified problems here in Maryland is the concept of new development versus redevelopment. And we have a sharp break in the benefit or the credits associated with redevelopment. Redevelopment has to provide improvements or water quality for 50% of the impervious surface that's already on the ground, or it has to remove 50% or some combination. But in new development, essentially a greenfield, which this project was, you really have to start from square one and control the full 1 inch. And so a reality check here is, how would this project be different and rethought if that if we had to break it down into, and these are quarter acre, these are 10,000 square foot drainage areas. But quite likely you could break those down into 2 or 3 smaller drainage areas. So the whole concept of ESD has really integrated planning, engineering, environmental science all into one package, and it's no longer the case where you can start to develop a plan without really thinking through at a high level of detail these sorts of practices at the early planning stages. Just a real quick example, again, I'm posing the question. One of our original green cities is Savannah, and yet these green areas, the boulevards, the parks, are absolutely beautiful and gorgeous, and they act as public amenities and benefits. They also act as cooling features within the town to keep it cooler because it's in the lowlands, low country. But these green areas are not ESD features. So how would we rethink a place like this? Well, here in Maryland, this is an example. This is a DPZ project. It's in Rockville, Maryland. It's a redevelopment of an office park along Interstate 270. And the idea here is total integration of ESD concepts from the as a redevelopment project. And again, this is benefits because it has more than 40% of the existing ground area in impervious cover, so it doesn't have to control the entire new limit of disturbance, but only has to control the 50%. And so the concept here is to integrate new buildings with green roofs, integrated bioretention within the street systems. There's going to be dry wells and things like that, and then a series of caps, so to speak, on the parking decks. These are trellises to help remove some of that impervious cover, essentially, from the stormwater process. But yet, this was designed before the ESD legislation occurred. So some of this may have to be reevaluated. These drainage areas may be too large, or there may be other features that may not specifically meet this criteria. So these are the questions that we're going to walk through during the webinar series here that may or may not be a problem in your areas. You may have resolved them, and we'd love to hear from you if you have. But these are problems that we're going to start to talk about here in Maryland and try and resolve the next round of amendments to our statewide design manual. So at this point, I'm going to turn it over to Mike Wagner, and he's going to walk you through some of the more technical ends of the stormwater.
Thank you, Dave. Very happy to be here today. This is sort of a very brief legislative history, starting with the Federal Water Pollution Control Act in 1972, and primarily dealing with how Maryland has tried to implement it locally. I'm bringing up my screen here. And in 2000, Maryland has passed a law that mandated that the first inch of rainfall would be treated for water quality, and a one-year storm would be controlled back to what's called extended detention rate. For the Maryland area, and this applies to other parts of the country but not everywhere, The bank full elevation of a natural stream is approximately a 1-year storm. So by controlling that 1-year storm, as opposed to a 2-year or a 10-year, which was in the previous laws, you have a better chance of not causing erosion. So some of the other things about Maryland area, and this does vary across the country, 85 to 90% of all of our rainfall events are less than 1 inch, and effectively 80 to 85% of the total rainfall volume in 1 year would then be treated or peak controlled by these devices. That's an awful lot of water. The old style of stormwater management allowed you to put in ponds or underground facilities when you got into very dense areas, and you still could address downstream flooding in the ponds by controlling it to a 10 or 100-year storm. Now, put together a little bit of information about rainfall from around the country. And where I work, which is in Prince George's County, Maryland, our 1-year 24-hour rainfall event is 2.7 inches. As you can see in Charlotte, North Carolina, it's 2.8. Out in Tucson, it's 1.4. That's a very big difference as to how much water you either need to control or how you might want to size a device. Tucson might allow twice the area coming to each device that we would in our area, so you don't hydrologically overwhelm a facility. Now, this would have been a typical water quality facility designed back under the 2000 law, and it would have been treating the 1 inch of rainfall for the area that drains to it. This is, as you can see, it was done in 2003, and it's still going pretty good. And this was a facility that was installed about 3 years ago, and it had just been completed at this time. It serves a 242-unit condos project, and this is the smaller of the two facilities. But again, it's designed just for the 1 inch storm. In 2007, Maryland changed the law. They were concerned that we still had water quality degradation, there wasn't enough groundwater recharge, and the low flow volume during dry periods just wasn't there in the streams. Plus, extreme erosion was still occurring. So they came up with environmental site design to the maximum extent practicable. And this is what makes it a little bit more interesting than what has happened in the past. They're requiring a more holistic, integrated approach to design. They don't want a planner to put something together to turn it over to an architect who then turns it over to an engineer in order to do design. They want all of the people to be involved up front to evaluate what you can put out there and what environmental features you need to preserve and how you're going to meet the goals of the law. The good news from an engineering point of view, the total water volume is still similar to the 2000 design manual, and they do now require, or they're trying to require, that you can take your water quality volume, which is your 1 inch storm, and combine it with your channel protection volume, which is your 1 year storm, and you put it in a lot of small devices with very small contributing areas. A good way of thinking about it, instead of having a big stack of pancakes on your plate, you're taking a whole bunch of silver dollar pancakes and scattering them around on the table. That's sort of a visual type impact. And this is ESD to the MEP definition for the Maryland law. Using small-scale stormwater management practices, non-structural techniques, and better site planning to mimic natural hydrologic runoff characteristics and minimize the impacts of land development and water resources. And so what they're trying to do is save trees, cut down on impervious surfaces, and I'll talk about that a little bit later on. Put your devices as close to the building as possible, or as close to where it's occurring. Don't let it get into a storm drain pipe, flow a distance, and then before you start treating it. And start using other non-structural practices or innovative technologies approved by the state. Now, they've set up this 3-step process. A concept plan, also locally known as a stormwater concept plan. A lot of people may understand that as something like a schematic design plan. Then you have a site development plan. This is where you've got pretty much you've got your design done, you've got your grading done, you've got your volumes correct, you're working it in with the homes or the buildings that are being constructed with the paving. similar to a design development type level of in a project. And then the final plan, which is your 100% construction drawings. This is a matrix that was put together for Prince George's County, and I don't know, there's the mouse. They have a number of practices: green roof, permeable concrete, reinforced turf, disconnection. So we go across 6 different items there. Then you're looking at soils, high groundwater, who's going to do the maintenance, the type of residential that it might apply to, or the drainage area for the individual practice. So using, we'll take permeable concrete. I have a B soil, so yes, I can use that. Who is going to maintain it? Well, usually that's on a private area, so the local county DPW will not maintain it. It's going to be privately maintained. They're not going to allow it in the road right-of-way. It could apply to any residential lot of any size, multifamily. It could apply to commercial. And then the drainage areas is limited to greater than 10,000 square feet, which is good. And these are a couple of examples. The one on the left is a green roof. The permeable concrete is the red shaded area on the street. And then you can see some reinforced turf on the right side. And then we continued with the various types of micro practices. So you have rainwater harvesting, such as cisterns and rain barrels, submerged gravel wetlands, landscape infiltration, infiltration berms, dry wells, microbioretention, rain gardens, grass swales, bioswales, and then sort of and then also wet swales. And again, we have the same setup where you look at the individual soils, the hydrologic soils group from SCS. In our area, we have something called Marlboro clay. That's very bad stuff to build on. If it gets wet, it slides. So if there is something building on, if something's going to be built on it, you have to approach it in a much different way. That's part of the concept plan. You want to identify that and identify how you're going to deal with the Marlboro clay, or if you have something similar. And so if we take microbioretention, which will be a popular device in this area, we can see that we want to try and put it in where the area is 5% or less. That's the surrounding graded area. I can put it on an A or B soil. And I've lost my mouse. There it is. On a C or D if I put in an underdrain. Same thing with Marlboro clay or compacted fill. It's going to be maintained privately. And the county at this time was only going to allow it on common areas. They weren't going to allow it in someone's backyard. And then, of course, it applies to a commercial area. Stormwater hotspot, they don't want that because they don't want the water going into the ground as infiltration. And then the drainage areas, it's good up to about 20,000 square feet of impervious area. And then here's sort of a little graphic showing the different types of devices and some of the maximum areas that would drain to them. Now this is a little microbioretention facility. It's just maybe 2 parking spaces wide and 2 deep. And this is what they're looking for doing microbioretention. This happens to be at the county building, which makes it easier to not necessarily maintain, but at least keep an eye on to see how it's working, because as the public comes to pick up a permit, they can start getting educated about what's going on and what they're going to have to do. And this is a typical, another example of how you might implement microbioretention in a site. One of the problems with microbioretention, rain gardens, landscape infiltration, at least in Maryland, is that there is a planting media, and also known as a made soil. And it's sort of a combination of sand, leaf mulch, or something similar to that, and topsoil. You don't want any clay in it. That has to be handmade. You just can't bring in soil from elsewhere and use that. So it's Gets much more expensive to construct something out of bioretention, but it is very effective in doing pollutant reductions. In general, what we're finding in Maryland, because of our rainfall amounts, that if you're going to put in surface features, you're going to need 15 to 20% of your site is going to be need to be set aside for these features. You have to start counting on the fact that they're going in. It could reduce building square footage. You may not be able to put in some of the site improvements you'd like to see, and you may end up with a slightly less dense development, and by that I mean fewer units or less square footage. The ESD green space is not available for passive or active recreation unless structural measures, or then if you need that, then structural measures would be required. However, one benefit is if you set aside an area for stormwater management, which is usually 5 to 7% of a drainage area, you would be able to use that to help achieve or make up some of your density loss. Some other problems, the denser the development, the more difficult it is to achieve environmental site design without structural practices. The intent of Maryland law is to not forbid structural practices such as an underground facility or a stormwater pond, but to encourage you to do everything possible to avoid it. However, if you have to have a very dense project, especially if you're going into trying to do smart growth, it begs you to put in underground stormwater management. You need to start looking at what impervious areas can you remove. Can you end up with a narrower road? Drive aisles. If you have a 25-foot drive aisle mandated by your local jurisdiction, can you get by with 22? Can your parking spaces be 9 feet wide as opposed to 9.5? That saves you 10% green space. You keep the same number of parking, but if you can cut the parking bays down by 10%, that's green area that's area that you're going to be able to use to create the green area to help treat that. You also have to be able to get buy-in by the user. That's either the homeowner or the property owner who has it on his site. And something we have found recently, linear projects approach 100% increase in right-of-way to accommodate these practices. And this is a good example of this. This is a road that's going in right now, and every one of these is a micro bioretention facility. This is a 4-lane road, and as you can see, it has a dramatic increase on what's going on for impact to the environment. General design considerations. Look for low-hanging fruits. Dry wells don't take up space. Surface-wise, use them. They're also a little bit cheaper. If you can get something to have more than one function, use it. Porous paving acts as paving. A green roof is possible. Both of them are more expensive. When you have landscaping requirements, use your landscaping islands in order to meet your best management practice requirements. Consider cisterns. Those are very useful for getting water off a roof, holding it, and then using that either for landscaping irrigation or reuse in a building. That's a very big, important consideration, especially in areas that have drier climates. You also need to make it constructible. I know people like to have something looking natural. Can you actually construct that? It gets very difficult using machine to do very sharp curves, which means you're then going to hand labor. That slows down the whole process. Rectangular is great, but I know it doesn't look very natural. You also have to make sure that someone can maintain it. How do you get to it? What sort of access will be provided? A maintenance schedule. How often do you have to come out there? Lack of maintenance means all the money spent to construct the ESD is just being washed down into the stream, and you don't get any effective pollutant removal or peak flow control. And I talked about the made soil earlier. We're finding that costs over $100 a cubic yard in this area, and cheaper alternatives need to be found. This is sort of a little guidance menu for water quality features. And I'm going to concentrate, because this is smart growth, on the street tree system. If you have about 120 square feet of a street tree system, you're able to treat 1,000 square feet of impervious area if you're doing our ESD, the MEP, which is our 2.7-inch rainfall, or 2,500 square feet if it is just the 1 inch of rainfall. We've put together the same table for a hydrologic sea soil. Now, this is a typical section when you're trying to densify an area or in an existing area, and you don't have a whole lot of room out there. You have your street area, and you have your water and sewer facilities running here. You've got your storm drain lines for along the curb. You've got your gas, electric, telephone here. So you've only got a little bit of area right in here to do stormwater management. And so you also have to look at your streets. How are you going to design your streets so that you can try and utilize what green you are able to achieve? The normal street in most subdivisions is a crown street. Water drains to each side. If it drains into the middle, it's hard to, if something clogs, it's very difficult to have people drive through, and it just becomes a very difficult maintenance issue. Double crown street, you have water draining to each side of a boulevard. A reverse crown, this is where you actually do drain it into the center. They were done years ago. They're not done too often now. However, if you have an island in there, that may be an approach to go. You can also drain everything to one side so that you have, if you have a much more dense pedestrian usage on one side, you use the other side to put in some of your green infrastructure. And then, of course, you can have a very flat street, and then you're looking at more porous pavement or something along that line. This is another sort of a view of what you had seen before. And to try and get into the street tree system I talked about, you're looking at putting in little devices that take water over to here, there. You might combine this so that it is also active and maybe plant some shrubbery, and you'll see some examples in a few minutes. The whole idea is to integrate this into one large system or larger system so that you can pick up rain or runoff from the roof or from a road. And this is another example. This is an old, very wide sidewalk here with an idea of, well, let's put our street tree system along here. We'll bring the water in along this way, and all of a sudden you have a much nicer boulevard to walk on, and it looks much more inviting for people to come and visit. A couple of examples of how you might drain water off of a street. This is more of a suburban type solution. This was done recently in the town of Edmonston in Maryland, and they put in sidewalks, LED lights, lights that shine, and the optics are set up so they shine down, don't shine up, and then they have bioretention established right in here. This may not be practical in areas because it's going to be a maintenance issue. Turf can work, but in some areas this would work very nicely, and it gives you a different character along the street. Here's one where you have some pedestrian use, not a lot. This gets a little bit more problematic if you have a lot of pedestrian use because it's a relatively narrow sidewalk. You also have a problem off along the street, and that if there's parking along there, you cannot get out. So you have to think about that. Here's an example where people are able to get out along the curb, and they even have walkways leading back. This is a much more urban type of environment and very attractive. And here's another example in a urban type environment. You do have a little bit of opening along the street, so you're able to get out. You can see the protection along the curb there. You have to think about the pedestrian usage to make sure that someone doesn't just fall into it. This is probably a foot or a foot and a half deep, so you don't want people just falling into it and get hurt. This is a more urban solution. It's a little 6-house cul-de-sac, U-shaped road, about 15 feet wide, but all the water drains right into the middle. So you have this nice green area in the middle, to help augment the landscaping on the streets. Now, one of the things I really emphasize in all my talks is maintenance. Part of what Maryland is going through is also something called WIP, which is the Watershed Improvement Program, and they're requiring all the jurisdictions in the state, and actually it's part of the EPA requirement, but they're requiring all those jurisdictions in the state to make a lot of improvements into their wastewater, septics, agriculture, and urban. In my county, which is about 900,000, Prince George's County, and the adjacent county, which is Montgomery County, which just has about the same population, they're going to be spending approximately $2 billion each in the next 10 to 12 years to try and meet these goals. And so that goes to my first point. Lack of maintenance means this investment by the county agencies or developer, if you have a new subdivision, as part of the development, is being wasted. It means that the stream cleanup goals will not be met. It also means lack of maintenance could include filling in the device by the owner. You know, if someone in a subdivision doesn't like his rain garden, he'll fill it in. Well, that's affecting the stream. Bankruptcy, diversion around a device failure, or just plain neglect. So this is a slide I showed earlier, and this was in 2008. This is this 242-unit condominium project. And this is what it looked like when it was first planted and ready to start receiving water. It then proceeded to go into bankruptcy, so they had just a few people living in there. And of course, when you're in bankruptcy, you don't have a whole lot of money, so it has slowly gone downhill. And then as you can see, this was taken about 6 months ago. It's basically a clover field. Looks very ugly, and this has now been converted to rental, but I know that if I was living up here in these units, because it's 4-story and looking down on this, I wouldn't be very happy. The good news is it is performing its function. It's not ponding water because there is an underdrain in there with a lot of gravel, but it still is a very ugly-looking little area that we don't want to see happening. And with that, I will turn this back over to Dave.
Thanks, Mike.
Thank you.
One of the things I think, if it wasn't apparent, is we were looking at some really great examples from California in the examples that Mike brought up. And I don't quote me on the number, but I think California's rainfall is about 40% of that of here on the East Coast. So they're able, because of just the quantity of water they're treating, to integrate better into the urban environment these features. So and they're absolutely beautiful. But that's the challenge we're having. We have a substantially larger quantity of water. So getting back onto the ideas and thoughts that we had as to how to solve some of the problems that we've identified. We did this presentation yesterday, and we basically indicated that we have really more questions than answers, but we have identified problems that we want to work towards solutions. And I want to start with scale and organization, and really the whole concept of smart growth being the best management practice for storm and stream quality. If we were able to develop our places in the logic of place types with cities, towns, villages, and hamlets located along logical corridors, and integrate that with a network of green systems, we would go a long way in substantially reducing our stormwater impacts. And the reason for that is we're building vertically. I mean, there's a lot of reasons to build this way, but from a stormwater standpoint, the denser we go, the more vertical we go, and we're able to capture more quality per capita than you could if you spread things out. And so very quickly, LEED, CNU, and others have really identified a great organizational process of looking at the region first, the neighborhood and pattern second, and then the specific place and block third. And the ideal arrangement of pieces is to create these places is a small downtown. This is about a mile square, just to give you a sense of scale. 4 individual neighborhoods surrounding that downtown, all within a 10-minute walk of potential transit site. And there may even be a little bit of fringe development, larger lot development along the edge that may not be dependent on transit. But this particular system can set up a 1-to-1 jobs to housing ratio and handle it at 7 dwelling units to the acre, 4,000 to 5,000 residential homes. This is a plan prepared by Doug Farr Associates, where he's taken the first step and Doug was the chair of the LEED ND committee that developed the LEED ND system through U.S. Green Building Council. And he's taken that neighborhood concept and he's integrated a lot of green systems into that neighborhood. He's got green boulevards, integrated parks with stormwater. You've got the habitat corridors. You've got dual access, recreational corridors, all contributing to the water quality benefits of this kind of new sustainable neighborhood. But what you don't see here is that very small drainage area ESD facility. So this doesn't necessarily meet the criteria that we have here in this area. So one of the things to look at is the town as a series of systems. Just like a car has a series of systems, has a brake system, a fuel system. Well, the town has a series of systems as well, all needing to work together in some sort of seamless pattern. We're focused today in this conversation on water and more specifically on storm cleansing, but that really relates to a lot of other factors, and we'll go into that. One of the things that we do here is we look at it as a complete town planning methodology. So we drill down to its integrated ESD practice as a part of the filtration system, for example, and we may look at native grasses as an example on this particular slide. And here's a picture of that. Now, one of the things I want to raise as an issue, and it's not something that's unknown to folks, but it's something that we have a challenge here, is our design manual, the approved practices here in the state, basically look like this. They're very suburban, very natural. They follow, they need a lot of room, basically. And yet, we want them to be more integrated into the, and again, we're talking about smart growth or higher density sites. We want to be integrated into the fabric of that place, more like this example, again, from California. So one of the challenges, or one of the issues that we've raised, and we want to talk more about, is the whole concept of space efficiency of these facilities. Mike touched on it with dry wells. As one of the approved practices, dry wells are not only inexpensive, but they are one of the most space efficient of the practices. Here in Maryland, the available options we have, which we'll go through a little bit, are very limited, and some of them are very costly. So we're going to go through the cost analysis and the treatment, and what I'd like to refer to as the treatment efficiency of each one of these. How efficient are they in treating a certain volume of water, a metric of water, and how does that compare to the other facilities, and how does that compare to the cost of those facilities, and then finally bringing that cost into the context. Now, these are going to be very visible facilities. They're going to be everywhere over time. And so the question of visual quality is something that I want to raise as well. Here's that slide that Mike showed you earlier. These are the approved practices here in Maryland for alternative surfaces. Here's the cost of those facilities. The uppermost, now I don't have a good number for reinforced turf, and I apologize for that, but starting with the green roofs, there's a recent study been done both by the Home Builders of Maryland and the University of Maryland Systems, 2 different studies actually, and these numbers are from those 2 studies. And it looks at the initial cost the first number is the initial cost for treating an impervious acre, and that's 100 for the green roof. That starts at about $146,000 to treat that. The middle number, $164,000, actually starts to include some of the maintenance over a 20-year period of time, and then ties that back into the overall cost. So it's a marginal increase as a result of the maintenance cost, but there is a cost of maintenance beyond just initial construction. The lower number, $110 to $220 per cubic foot, that indicates how much it costs for that installation, and that's initial cost, not maintenance, to treat 1 cubic foot of water. And when we jump over to the alternative surfaces, you can see the numbers change. They're roughly in the same category for initial construction at the low end, but they jump dramatically, and that's because of the permeable pavers that are very expensive, and that distorts the numbers a little bit. And then the maintenance costs are very, very high for this particular practice. So for to look at that as a solution, it has to be used in a very limited capacity as a solution. Otherwise, your maintenance costs are just going to be exorbitant. The lower numbers are broken down for each of the paver types: permeable pavers, permeable concrete, asphalt, and then sidewalks. And you can see that the asphalt and sidewalk systems are the more cost-effective of the 4 options. And again, this is an earlier slide that shows the particular ESD micro practices that are allowed here in the state. And here are the costs per cubic foot. And you can see that some of the, can I say, uglier features are the least costly. And one of the fears that I have as a landscape architect is the potential to have cost be a driving factor in the only driving factor in some of these installations. And the inappropriateness of grass swales in an urban context is a problem as well. But you can see the dry wells are coming in at a very, very inexpensive rate, and again, they're not a land hog, and they're a great opportunity. The rain harvesting systems as a treatment option, not necessarily just for rainwater harvesting for irrigation and that sort of thing, but just looking at it as a treatment option, is relatively high compared to the others. What's interesting, this is and it's poor quality, and I apologize, but this is an interesting graph that takes those practices and applies them on the left-hand column as an initial construction cost of construction for per cubic foot of water treated, starting at the bottom at $5 up to about $250. And then along the bottom axis, we have our drainage areas, and we're starting at 1,000 square feet, 2,000, up to an acre in size. And you can see that certain practices are limited by the drainage area that they're allowed to be used for. Other practices like dry swales, wet swales, submerged gravel wetlands can actually treat much larger areas. So when you start to look at this, you can see that the dry swales, the swale systems, are the most cost-effective, not necessarily the best from a land usage standpoint. And also you can see that rain barrels and rain harvesting basically treat a very small area and have a higher relative cost. In the urban context, we may not have any alternatives but to do green roofs because of the nature of the site, the nature and character of trying to get more density. We're trying to do in this area some sites that are FAR 3.0 to 4.0 and higher, and then integrating these systems. So green roofs in that context make it a much more viable solution because you're adding it onto a more expensive building system versus trying to apply it to, say, a single-story warehouse building, which would not be cost-effective. This is the summary printout and it's again a draft report. This is from the University of Maryland, And this is one of the first studies that starts to take into account pre-construction costs, the planning dollars associated with it, and the cumulative dollars that start to be applied to the maintenance of the project. It starts to look at an annualized or a 20-year annualized cost for each of these facilities. And again, as we showed on the previous slide from the home builders, the green roofs are at the high end, and the permeable pavers, the alternative surfaces basically are at the higher end. And then the grass swales and more suburban solutions are at the lower end of the cost scale. So one of the problems that we yes.
If I may point out, that is part of the WIP requirements, and that's only treating the 1-inch rainfall for those impervious areas.
Thanks, Mark. One of the problems that we have here in promoting smart growth and integrating it with ESD is the misconception that a denser place provides a greater level of runoff and pollution. And that's generally true if you're looking at places on an acre-by-acre basis. And this particular drawing from Potomac Conservancy basically shows that, and it's true. You have less infiltration in the more urban areas. You have lower levels of evaporation, and you have higher levels of surface runoff. But when you look at that on a per capita basis, the numbers come way down. And here's an example from the EPA. This is, I believe, generated through the Congress of New Urbanism. And to make a long story short, this is a quick study to show if you spread 80,000 homes over at 1 acre, 1 acre lots, or 1 house per acre, I should say, you can see at the bottom it generates 1.5 billion cubic feet of stormwater runoff that has to be controlled. At the other end of the scenario, scenario C, you can see that that same number of homes, if stacked vertically in one watershed, only generates 400 million cubic feet a year. So you can see that clearly just the concept of smart growth is a tremendous advantage to protecting our streams and the quality of our streams. The problem that we're having here in Maryland is unless you're defined as redevelopment, which has still got some pretty significant requirements, the home that's out here in the hinterlands has the same treatment requirement as that same 1 acre or home here in this scenario C. So they're being treated the same. There's a disadvantage built into the law, unfortunately. So one of the comments that we have, or one of the suggestions, is to start to look at this more on a regional basis, to start to look at the entire watershed and have different application scenarios or calibrations within the watershed for stormwater control. And it's more, and again, we're referring to the Maryland law where we have this flat requirement across the watershed, and then if your redevelopment, 40% of your existing ground is already in impervious cover, then you have an advantage. The second point that I'd like to make associated with this watershed analysis is currently our law has a, and it makes sense, but it has a requirement for impervious cover. The way the law is done, the way the numbers are calculated, the way projects are going to get approved, really is in essence comes down to how much impervious cover you have. And obviously in a more urban environment, you're going to have a higher level of impervious cover. And if the existing ground is green or 39% or less in pavement, then you're going to have a much higher standard to meet than may be appropriate. And it may be more appropriate to have if you're looking at smart growth, you may want to have a higher requirement for folks that are actually out building 1 and 2 acre subdivisions. Maybe they should be paying a higher percentage, going back not only to the cost of service for those areas, but also the amount of turf that's being generated and the nutrient loading associated with that turf. But this is an example. This is really quickly 5.6 acre site. We have 3 acres of impervious. We're on a hydrologic soil type C. And the numbers that, if you go through the calculations within the Maryland law, we're going to have a target rainfall of 1.8 inches. We're going to have a total ESD requirement the 2.7-inch rainfall that Mike had mentioned of about 19,000 cubic feet. The water quality, the 1 inch, is about 10,850, and then we have a recharge number, and we have a phosphorus reduction number as well that comes out of those calculations. When I take that same land area and I take the same number of homes, the same density, but I rearrange it to reduce my impervious cover. I've now gone from 3 acres to 2.3 acres, and I've done that by using a cul-de-sac. My numbers, my stormwater responsibilities under the law come down. So there's an inherent disadvantage to doing walkable, integrated, connected street systems and alley-loaded homes because of the added imperviousness. So our suggestion in our conversations at the state level is that there should be some sort of calibration to allow smarter types of communities to be provided and not be disadvantaged just simply because there's a little bit more impervious at that particular smart growth site. So again, looking at a watershed basis. And quickly, this is the menu of ESD facilities or practices that would be required on that one cul-de-sac, and there's actually 43 of them to meet our ESD to the MEP that Mike had talked about earlier. And then the same, going back to our original proposal, with essentially 30% more impervious, we're providing some very expensive ESD practices. Again, remembering that the permeable pavements, which are the red lines in this diagram, are being provided in the alley and in the parking systems along the public streets, which is a whole other controversy. But even with that, we don't meet our ESD. So we don't meet ESD to the MEP with even showing 67 more expensive practices. So there's going to be a natural tendency of developers and builders not to do this sort of development if they're just looking at the cost of infrastructure and the cost of land and how that affects the way they do things. So they're going to tend to build towards a more impervious efficient system, which is the cul-de-sac system, which may not be the best social system. So our recommendation number one is to start to look at these solutions on a watershed basis, to have variable ESD criteria based upon a project's location within the watershed. Smart growth sites have a slightly different requirement, but the overall watershed would be protected. So that within the watershed there'd be a sliding scale of imperviousness. And then actually to build into the law some incentives for density, because again, going vertical, it's been proven time and time again, is a benefit to the not only to the watershed, but it's a benefit from a transportation standpoint and from a cost of services standpoint and those sorts of things. So an incentivized density opportunity within the law makes sense, measuring things on a per capita rather than a per acre basis. Our second point that we've brought up is that, again, Mike and I are in the private sector, so we haven't really, we've been telling our colleagues in the public sector, you haven't really seen the onslaught of these new plans because we've been in the deepest, darkest recession since World War II. And this is a graph that shows how dramatically job production has lagged in this recession than it has elsewhere. As it recovers, and when it recovers, there will be more redevelopment. The other thing that's happened here in Maryland since 2007, there's been a grandfathering provision that older projects have been grandfathered under the old stormwater laws, and that those have to be either constructed in 2013 or they expire. So right now there really isn't an onslaught of new work with all these complications. So we've been suggesting that folks try and get ahead of the curve and be proactive, have a strategic plan, put as many of these new design opportunities into their design manual so that you're not playing defense essentially when the economy recovers and when the, in our particular case, when the grandfathering stops. so that we start to look at things to, countywide or municipal level, start to look at mitigation sites for smart growth projects, start to define what MEP really means for a smart growth project, and then start to look at decision-making and design manuals that make sense for these projects. Our third concept or thought is that right now we have a flatline type of look at the way water is treated throughout the watershed. And really, it should be looked at more as a transect. And here's an example of best management practices suggested by the EPA again. And this looks at urban, suburban, and rural, and what's the most appropriate. The Congress for New Urbanism and DPZ have generated the rural to urban transect for a variety of purposes, including stormwater management. And it makes sense because it's really derived from our natural systems as an idea. And it really makes sense for everything, including stormwater. And really, it may we want to treat our areas that are natural and rural differently than our suburban areas. And then as we start to get into the urban growth boundaries, the general urban areas, those urban centers that are much more complex and much more land constrained, and ultimately our urban cores. So really what we need is a transect perspective as it relates to stormwater, and we don't have that currently in Maryland. I don't know if it's been resolved in other places in the country. But one of the things, again, going back to it, is this misconception that denser places provide more pollution, but it is true on an acreage, but not on a per capita basis. So you can see that going back to our old site, we start to add density. I'm going to go through these relatively quickly. You can start to see that as we add density, in Maryland, the problem again goes back to the fact that our existing impervious is 0. This is a greenfield site, so we have no matter how many treatment facilities, including green roofs, we put in, we are challenged within this urban context to meet our ESD requirements. So the question again is, what is the maximum extent practicable? Where does that line fall? And Mike and I are suggesting that that needs to be defined more, and it may need to be defined differently in the urban context than it is in a suburban or rural context. Again, jumping up again, we have a greenfield with a higher density site. It gets even worse. I'm not going to go through the numbers. We could if you'd like. And then when we start to add green roofs, it adds a beneficial, but we're still coming up short. There's a tremendous benefit to providing those green roofs, and that is going to be an important component as we move forward. And then the important thing to note here is when I change to 30, if I go from a pure greenfield to a 39% impervious, which is the only real change, my numbers really haven't changed that much because I'm treated the same as if I was a greenfield. But when even though it's 80% more impervious than some of these previous studies, but when I go to 40% impervious on the existing ground, what's referred to as redevelopment kicks in, and now I only have to control 50% of the site. It makes sense. That's the way it's written into the law. But that is a harsh break between those two. So, and I can tell you I'm working on projects where the impervious surface in major planned growth sites is under this 40% requirement. So our suggestion as we look at this is that we really start to think about a transect for stormwater management, more specifically how it's treated. So we want to calibrate this system to really strengthen smart growth goals and objectives. And we currently, our recommendation, our suggestion is the current law doesn't do that. It's too harsh a treatment. It actually, you know, if you have a high impervious surface, existing site, great, and it does recognize that, but maybe there should be some calibration between, say, maybe 20% and 40% as action item 2 recommends. We really think that rather than just leaving it up to the resolution within the development review process, there needs to be more definition of what MEP means in the smart growth sites, and then that calibration will hopefully help. Again, going back to our approved design standards, in these urban locations are really not appropriate. So we need to look at more integrated urban type of solutions. Unfortunately, I found out yesterday that this sort of process has to go through a bureaucratic review and approval process before it's even an approved practice. So I even more strongly recommend that these sorts of practices be developed now while we're in the economic recession, so they're available to developers when things start kicking in. Here again is our California example. So fourth recommendation or suggestion is to start to look at a performance-based design manual, perhaps, and this may be too much, but really get away from these legalistic typical sections, and perhaps we're hoping that, at least as a suggestion, we start to think about performance-based, making sure we meet those nutrient reduction requirements that may not necessarily be in the typical sections that are pre-approved by the EPA and the state level folks. Fifth recommendation, start to, in the private sector, you no longer design from planner to engineer, as Mike has talked about, this linear process. It really is a team approach, and it should be that way on all projects. Not necessarily is, but it has to hold true also in the public sector. The review process really has to be a team approach, and it has to be integrated. It can't be, you know, that's DPW's issue or that's planning's issue. It really has to be a team approach because these things are so integrated into the context of the built environment now. There's no way to not do it this way. And so I'm not suggesting you hire a bunch of interns, which this picture suggests, but really get around the table and start looking at that. Really start to get folks swimming in the same direction. So our suggestion is, if you haven't done it, and some places haven't done it, some have, but to start to reorganize the stormwater review system into an integrated team approach versus a departmental approach, and include planners, landscape architects, soil engineers, and the stormwater engineers all on that review team. One of my big concerns, again, as a designer, is the issue of visual clutter and pollution. And we have mandated and we have allowed this to occur throughout our country. And I am very concerned that the next visual clutter could be our ESD requirements if we don't really think about what these things look like and how they perform and the maintenance that Mike had suggested. So we want to integrate them into a comprehensive green street system into the urban context. And ultimately, these systems have to be visually appealing and they have to be maintained properly. So our sixth recommendation is, and we're using the word mandate, but the idea here is that beauty counts. The art of stormwater design is important and it should be seamlessly integrated into the process. Finally, Mike had mentioned that we're going to be using a lot more land. So the more land we use for a single type of use, stormwater control, takes away from the other uses available on that site. So we want to start thinking about stacking uses, multi-use, overlapping, and those sorts of things. And this is the example that Mike showed, where the actual stormwater system for this new road is actually greater in land usage than the road itself. So that may be the way it has to be, and that's the way our laws are written here in Maryland, may not be the most appropriate way to deal with these things. So just like we did in that rural context, let's start to think in the urban context. Here's another Maryland example. Start to think about those green ESD corridors prior to redevelopment. Start to redevelopment project, integrate those systems into that redevelopment corridor. And when you're done, they are seamlessly integrated, whether they're dry wells, the tree pits, the continuous tree wells, the permeable pavers, all of those practices that are available to us. And again, Mike had mentioned the limited space we have to work with. So it's most likely that our urban standards or urban street right-of-ways are going to grow as a result of this. So our next recommendation, again, is to look at overlaps, to look at and stop competing between different areas within the government. Allow overlaps between stormwater, forestry, utilities, parking, landscaping, pedestrian recreation, really start to integrate these things because the cost of land is so expensive. Recommendation number 8, really to integrate these, we're suggesting here in Maryland, we're starting to talk about the concept of stormwater clubs, the trading of nutrient loading between private entities, not between, we already have it for government entities. They can trade between agriculture and urban stormwater and those sorts of things at the municipal level. But start to talk about it private to private across maybe jurisdictional boundaries, which is going to get very complex, but that's a suggestion. Because really, in reality, water travels from one property owner to the other and vice versa. So our final recommendation comes down to maintenance or monitoring. In this particular case, we have water that comes from private property to public property and eventually into a bioretention facility. And again, you can see public water, and you may even have some public water in some cases going over private land. But the point is, who's really responsible for this particular micro bioretention site? And this is only handling 4,000 square feet of drainage area, and these are occurring all and up and down the street, and there's other multiple practices occurring throughout this particular neighborhood. So it really, I would like to end on the idea of having the ability to cross those jurisdictional boundaries and allow some sort of logical maintenance and monitoring system. Here's a gentleman out there maintaining his rice paddies with a little handheld sprayer. Really what we need is some sort of basic self-reporting and auditing system that's simple. And there's a lot of talk about this throughout Maryland right now, and the Center for Watershed Protection and other Chesapeake network has done a lot of really good work in this area. But elsewhere, this could be a tremendous nightmare, and the failure rates are really not being included in this system. So finally, I'd like to end. Our great places are integrated, flexible, beautiful, and performance-based. They're logical and they're complex, and our stormwater system should be a part of that system. And that's how I'm going to end there, and I'm just going to go through a few of the references that we have in the PDF very quickly. They're available to everyone who downloads the PDF, and they include national, Maryland, and third-party sources. And that's our contact information, and thank you very much. I'm going to turn it over to Brittany at this point.
All right, thanks, Dave. So we have a couple questions that have come in. I'm just going to switch it back over to you so we can leave up your contact information. If anybody wants to jot down the email addresses, you can send Dave and Mike some emails with your follow-up questions. But our first question comes in from Bradley. So it sounds like Maryland's approach is a top-down, one-size-fits-all. Is there local flexibility, for instance, to adopt stricter regulations or to limit certain types of solutions that are locally not deemed best practices?
Mike, do you want to take that, or do you want me to? Generally, it is a top-down approach. And it's only because the state legislation had to write in some specific criteria, and it's because we're within, substantially a substantial portion of the state, maybe all of the state, is within the Chesapeake Bay TMDL, and we have court cases, and we have a long history associated with that, and we have to, we have mandated responsibilities and legal ramifications if we don't meet our obligations. So it is a top-down approach. And no, the answer to the second question is yes, you can have a stricter standard at the local level, but you can't have a more flexible standard, and that's kind of what Mike and I had been suggesting. So that's the challenge. If that local jurisdiction could meet their obligations within the boundaries of municipality and maybe have one hotspot of outfall, but they compensate for it elsewhere within the jurisdiction because they have other opportunities or other reasons or objectives, is something that we're suggesting. But to answer your question, it is top-down.
All right, great. Our next question comes in from Lenore. In my experience, the city rights-of-way areas between the curb and sidewalk are generally reserved for utility easements. With the establishment of water quality infrastructure in these areas, how do the municipalities incorporate electric, cable, and other infrastructure lines?
Mike Wagner.
And while you're doing that, I might flip back to the slide.
Okay. In many counties in Maryland, our public utility easements, which is for electric, telephone, and gas, are located outside the public right-of-way. So we have about a 10-foot easement outside the public right-of-way where we put those utilities. Water and sewer tend to be in the public right-of-way, and the local public work departments do not like to see gas, electric, telephone in their right-of-way except for crossings. If you have them running in the green area, that makes it a lot more difficult to try and implement some of those solutions. Those solutions may then need to be forced to the outside further. You might also want to consider having those utilities run underneath the sidewalk, for example, or put them in the street, conduits, so that you don't have to rip up part of the yard or tear up an area in order to access it because it's in conduit, so you can pull a line, or at least you can minimize where some impact might occur.
Okay, great. So our next question comes in from Ellen. What kind of insight or ideas can the speakers offer about ways to include measures in the municipal code that addresses maintenance and retrofitting these BMPs, especially for a small or rural town?
Mike?
Well, what Maryland has required in their law is that you are required to report every 3 years, first from a owner of the facility to the local jurisdiction, and then the local jurisdiction to the state, which the status of your facility is. Is it working or not? They haven't had a whole lot of experience with the very small facilities yet because there haven't been that many built, although there are some. The larger facilities, which is your larger stormwater management embankments, they are supposed to be reported to the local jurisdiction. That's very hit and miss locally. Other than requiring it, I know that there's one city in the area that because they know what is out there, they send a letter to the owner every year saying, where's your maintenance certified by an engineer that everything is okay and operating. That's one possible solution right there, is send out letters to everyone who has the device and have them report back. That works for a commercial type development. I'm not quite sure how one is going to deal with the local residents. I don't have much to offer at this time. Dave, any ideas?
Well, we made this presentation to the Maryland Planning Commissioners Association yesterday, and we basically posed the question to them, is how in the world are you going to monitor essentially, 10 to 20 facilities per acre or more, and how in the world are you going to deal with, like Mike was saying, 900,000 residents in one county? It's going to be a challenge, and I don't know that anybody does have the answer. It's not necessarily because it's the wrong approach. It's just because it's so decentralized that it's beyond the capacity of some of the local jurisdictions. We actually were on a panel with Kathleen Freeman, who is from Caroline County, which is a rural county in Maryland. And just very quickly, this is a little off the question, but it's important, and it goes to the question. They're spending $275,000 on 5 demonstration projects, and they're essentially reducing nitrogen by 100 pounds. They need to reduce nitrogen by 14,000 pounds by law.
44,000.
Thank you, Mike. 44,000 by law. So that's multi-millions of dollars that this rural county of some 30, 40,000 people has to deal with. They don't have an answer. They're just starting to recognize the problem. They're trying to deal with it, but they have limited resources. And maybe that goes to the kind of the question that when you mandate something legislatively, it's got to get done. And these rural counties and rural jurisdictions are going to be really under the gun because of their limited resources.
Okay, great. Our next question comes in from Michael. Do the structural requirements for stacking stormwater improvements and usable green space make doing so unreasonable? Are there ways to make such stacking feasible?
Well, I'll take that question. It depends on the value of the land that you're putting it on. Again, our whole presentation has revolved around smart growth or high-density urban sites. And the value of the land usually outweighs the land usage requirement for the stormwater facility. So in these cases, it does make sense, depending on the practice, to double count it or double use it. If you have an urban tree planting requirement, to integrate those into the tree panel that Mike was showing in some of his examples. That's a double counting, or you know, from a standpoint of responsibilities of the developer. But it meets both the street tree planting requirement and the stormwater quality requirement, so why not include it? And there are some approved practices for street trees by the EPA, and they're allowed in this system. But in other places, in the more fringe areas, it doesn't make sense, and so you have to kind of weigh the value and cost of the land that is being absorbed by the practice and whether it makes sense. And when it doesn't make sense, and that's the challenge that we've had here in some of our more urban sites, you need to have the flexibility to go to a more costly but less land consumptive alternative, which is maybe what you're looking or suggesting. So hopefully that answers your question.
Okay, our next question comes in from George. Having a transect approach with variable treatment requirements to promote smart growth sounds rational, but it could place a higher per capita treatment burden on more suburban areas. Will this require a system of compensation similar to emissions cap and trade for air quality?
Well, I think that's a great question, and the more you delve into this and the more complex you make it, the more complex the solutions become, and I think you're absolutely right. That's why we're looking, we're talking about the private property owner to private property owner trading system, so that you're really not disincentivizing or hurting someone in the suburban areas, but you're incentivizing the growth areas, the places where you want the development to occur. And that property owner goes out and finds, similar to a transfer development right process where you're protecting farmland and you're building in a corporate limit somewhere. So your point's very well taken, but what it needs to be, to the extent possible, is a private-to-private transaction, so that it's not mandated through legislation, because that will get very complex. And that's what our suggestion about the stormwater clubs is all about, similar to transportation clubs and transfer development right private transactions.
Okay, I think we're going to have to end our session here. If we haven't gotten to your question, or if you still have any questions that you would like to follow up on, you can contact Dave and Mike. Their email addresses are up on the screen, so take a moment to jot those down. I'd like to thank Dave and Mike very much for the presentation. I think it was a really great session. Everybody enjoyed it. And for our attendees who are still in attendance, if you just want to hold on, I'm going to go through a few reminders just about logging your CM credits in just a moment.
Thank you very much, Brittany. I really enjoyed it.
Thank you very much. This was a lot of fun.
Welcome. All right, so for those of you who are still in attendance, I'm going to go through a few reminders. First off, to log your CM credits for attending today's webcast, please go to www.planning.org/CM, select today's date, Friday, November 11th, and then select today's webcast, Environmental Site Design versus Smart Growth. This webcast is available for 1.5 CM credits. Also, we are recording today's session, so you will be able to find a recording of this webcast along with a 6-slide per page PDF at www.utah-apa.org/webcast-archive. And this does conclude today's session, and I want to thank everyone again for attending.